Hi, I am Hemsha and today I am going to give presentation of software metrics and maintainability. My agenda for today, I will be starting from abstract and these are contents of my presentation with some of them with different title mentioned in my presentation. Abstract of my presentation is my presentation gives the importance of software maintainability, factors which affects maintainability, broad understanding of software metrics to predict maintainability. The aim of this presentation is to determine to what extent we can depend on software metrics in order to maintain the maintainability of software products. The suitable metrics to predict software maintainability are considered after conducting some small surveys. The importance of software maintainability. Normally during the creation of software, most of the analysis and planning is focused on creating and implementing the required functionalities of the software. The codes are written in very traditional and are not adaptable to change. So the analyst failed to determine the nature of software before some years. Software maintainability is one of the biggest issues for the organization today. Although figures vary, there are several surveys indicate that software maintenance consumes 60 to 70 of the total life cycle cost. This survey also reports that the maintenance costs are largely due to enhancement rather than correction. By using proper strategies and tools, this situation can be improved and thus managers can not only predict the upcoming risk in software but also can take preventive measures to so that the maintenance cost can decrease. The concept of maintainability. Maintainability of software can be termed as the ability of a software to change without changing the basic flow of the software. The IEEE standard of software engineering defines maintainability as the ease with which a software system or a component can be modified to correct faults, improve performance, or other attributes or adapt to change environment. According to ISO 9126, maintainability can be described in terms of four sub-attributes. Ensemblities. It relates to the effort required to diagnose defects or to identify parts of software system requiring changeability. It relates to the effort required to actually fix, detect, or make improvements. Stability. It is likelihood that unexpected side effects occurs as a result of making change of the software. Test Testability. It describes the effort required for testing the software. The concepts of maintainability. Practically, we assume that software is something which is not in a physical form. It should not require maintenance because only a physical product requires maintenance. Due to several internal and physical products require maintenance due to several interior and external factors. Unfortunately, that is not the case. Software can be termed as a biological organism which would exist within a particular environment but should also be capable to adapt whenever environment changes. The factors affecting maintainability are modularization, readability, programming language, standardization, level of test validation and testing, complexity and traceability. In the introduction to the software metrics, metrics are categorized in two groups, basically on project-based metrics and design-based metrics. Project-based metrics concludes of process, products, and resources. We would go into we would not go into much of detail as our paper is more focused on overall metrics. Over metrics fall in design-based group. Metrics are also sometimes divided into four groups. couplings, cohesion, and interface. Size of matrix, line of code (LOC), NIM, number of instant messages, TNOS, today number of statements, inheritance matrix, DIT, depth of inheritance tree, NOC, number of children, AID, average inheritance depth, cohesion matrix, LCOM, lack of cohesion in methods, LCC, loose class cohesion, coupling matrix, CBO, coupling between object classes, MPC, message passing couplings, and CF, coupling factors. Overview of object metrics. A significant number of object metrics have been developed in literature. For example, metrics proposed by Abreu, CK matrix, Lee and Henry matrix, MOOD matrix, Lowe's and Keats matrix, etc. CK matrix are most popular amongst them. Another comprehensive set of metrics is mood matrix, metric for object-oriented design. Our focus will be on CK, which is Chingram and Karam matrix, and mood matrix. Different types of object-oriented metrics. CK matrix. And there are six metrics for OOD proposed by CK. First one is the weight method per class. The VMC matrix is a sum of complexity of all class methods. It is an indicator of how much effort is required to develop and maintain a particular class. A class with low WMC usually points to greater polymorphism. A class with high WMC indicates that the class is complex and therefore harder to reuse and maintain. Second thing, the depth of inheritance tree, which is DIT. DIT can be determined as the maximum inheritance path from the class to the root class. As we go deeper a class is inheritance, the greater the number of methods it is like to inherit and make it more complex to predict its behavior. Deeper tree constitute greater design complexity. Since more methods and classes are involved, the deeper a particular class is in the inheritance, the greater the potential reuse of inheritance method. Third, number of children, NOC. The NOC is the number of immediate subclass of a class in hierarchy. Greater the number of children, greater reuse, since inheritance is a form of reuse. Greater the number of children, the greater the likelihood of improper extraction of parent class. Coupling between object classes, which is called CBO. CBO is equal to number of classes to which the class is coupled. The CBO relates to the notion that an object is coupled to another object if one of them acts one of the other, that is, method of one use method or instance variable of another. Two classes are coupled when methods are declared in one class and uses a method or inheritance variable defined by other class. The uses of relation can go either way. Both uses and used by relation are taken in account. Fourth one, the response of a class, which is called RFC. RFC is the number of distinct method and constructor invoked by the class. The last, the lack of cohesion in method, LCOM. LCOM measures the method in a class by looking at instant variable or attribute used by method. LCOM is a count of the number of method pairs whose similarity is 0 minus the count of method pairs whose similarity is not 0. Different types of object-oriented metrics. Now we will focus on mood metrics for object-oriented design. The mood matrix set refers to basically structural mechanism of object-oriented paradigms such as encapsulation, inheritance, and polymorphism. Um, the first method is method hiding factor MHF. MHF is a sum of the invisibility of all methods defined in all classes of total number of methods defined in the system under consideration. This is the formula for MHF. Now the second one, the attribute hiding factor, is this AHF is the sum of invisibility of all attributes defined in an all class or total number of attributes. The formula is as below. Then the third method is method for inheritance factor. IMF is a ratio of sum of inheritance method in all classes of system under consideration to the total number of available methods for all classes. And the formula is MIF is equal to as follows. The attributes inheritance factor AIF. AIF is the sum of the sum of inherent attributes in all classes of a system under consideration to the total number of available attributes for all the classes. The polymorphism factor PF. PF is a ratio of actual number of possible different polymorphic situations for class to the maximum number of possible distinct polymorphic situations for class. Coupling factors. The coupling factor is defined as ratio of maximum possible number of coupling in a system to the actual number of coupling not imputable to inheritance. The overview of analysis. I had analyzed a research conducted by Venley and Shelley Henry on object-oriented matrix that predicts maintainability. My analysis is completely based on the research, and I have considered the research to prove that object-oriented matrix can predict the maintainability. This is the analysis done by them. There are dependent variable and 10 indeterminate variables in full model. Overview of my analysis. In GMIS system, more than 90% of the total variance in maintenance effort is accounted for by the matrix in sample and more than 87 in the population. So we can conclude that the maintenance effort for matrix can be predicted. My conclusion for this paper. At the end of this paper, we can say that all the questions have been answered briefly and in a manner in which the reader can understand easily. By successful analyzing the case study of the report developed by Venley and Shelley Henry, we achieved our final conclusion that object-oriented matrices are extremely useful, reliable, and successful in predicting the maintainability. Thus, if more research is carried out in this area, then the maintainability cost can be decreased to its lowest level. Here are the list of references of IEEE papers and some online materials. Thank you.